All right, in this video, we're going to talk about section 5.5 dealing with systems of inequalities. And in this section, we're going to be graphing a linear inequality in two variables and also graph a system of inequalities. Okay, first of all, the equations that are in the form of ax plus by plus c are straight lines when graphed. Okay, and that is because the highest exponent in the x is going to be a 1. So it has to be a linear equation. And they're going to be graphs consisting of straight lines. Now, if we change the symbol equal to one of these inequality symbols, less than, greater than, less than or equal to, or greater than or equal to, then we obtained a linear inequality in two variables, which is what we're going to look at in this video. A solution of an inequality in two variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the inequality, we obtain a true statement. Each ordered pair solution is said to satisfy the inequality. Okay. Now let's look at how to graph a linear inequality in two variables. Okay. All right, the graph of an inequality in two variables is a set of all points whose coordinates satisfy the inequality. A half plane is the set of all the points on one side of the line. A half plane is the graph of a linear inequality that involves either less than or greater than. The graph of a linear inequality that involves less than or equal to or greater than or equal to is a half plane and a line. And here a solid line is used to show that a line is part of a solution set. Whereas a dashed line or dotted line is going to be used to show that the line itself will not be part of a solution set. Okay, so here's the procedure for graphing an inequality in two variables. One, you're going to replace the inequality symbol with an equal sign and graph the corresponding linear equation. You'll draw a solid line if the original inequality contains a less than or equal to or greater than or equal to symbol. So if you have a less than or equal to or greater than or equal to in your original inequality, you're going to use a solid line. Now you're going to draw a dashed line if the original inequality contains a less than or greater than symbol. So notice less than, greater than, those two do not have the equal to sign underneath it. So that means that the line will not be included. So you'll draw a dashed line or a dotted line. And then second, you're going to choose a test point from one of the half planes. Here, you're not going to choose a point that's going to be on the line. You want to choose a point that's in one of those half planes and then substitute the coordinates of the test point into that inequality. And if you get a true statement, that means you will shade that half plane that contains the test point. If you end up getting a false statement, then you're going to shade the half plane that does not contain the test point. Okay. All right, now let's look at a few examples of this. So here we're going to be dealing with just simply graphing an inequality like this one. In example 1, you got 4x minus 2y is greater than or equal to 8. Okay. So here's the first thing I'm going to do here. I'm going to treat this inequality as if it was an equation by replacing that greater than or equal to symbol with just a plain equal to. So I'm going to be graphing 4x minus 2y equals 8. I'm going to graph 4x minus 2y is equal to 8 on the coordinate plane. All right, notice that the x and the y are on both sides of are on one side of the equation, and the numerical term is on the other side. The way I would graph this would be by using what they call the x-intercept and the y-intercept. Here's how we find the x-intercept. In case you need to be, if your memories need to be refreshed, anytime you find the x-intercept, you let y equal 0 and solve for x. So I'm going to substitute 0 in for y in that equation and find out what x is going to be. So this will be 4x minus 2 times y, which is 0, and that's equal to 8. And when I do that, this 2 times 0, that's going to end up being 0. So you're going to be left with 4x equals to 8. And then to solve for x, we're multiplying by 4. We divide both sides by 4. So that means x is equal to 2. That would mean that the x-intercept would be the ordered pair 2, 0, because I let y equal 0, and x ended up being 2. X comes before y, so it'll be 2, 0. And now for the y-intercept. That will be the point where the graph crosses the y-axis. So here, we always let x equal 0 to find the y-intercept and solve for x. So we just substitute 0 in for x in that equation. So it'd be 4 times x, which is 0, minus 2y equals 8. And here, 4 times 0 is going to give us 0. So you'll be left with a negative 2y equals 8. And then to solve for x, we divide both sides by negative 2 to get y is equal to negative 4. So the y-intercept would be the ordered pair 0, negative 4. Now, since it only takes 2 points to make up a line, I'm going to go ahead and plot those intercepts on the coordinate plane. My x-intercept is 2, 0. So I go to the right 2 and draw the point on the x-axis like this. And then the y-intercept is 0, negative 4. So I stay at 0 and go down 4 and draw the point. All right, now I'm going to draw the line. This inequality symbol will tell me that I need to draw a solid line or a dashed line. This is greater than or equal to, that means that the line will be included. So that means I'm going to be drawing a solid line. Okay, so I'm going to connect my 2 points here. And I'm going to draw a solid line. Okay, so that's a solid line. Now, to determine whether I need to shade this part of the plane or this part of the plane, I need to pick a test point. Okay. And I'm out of room here, so let's see here. I'm going to write test point over here. Now, you want to pick a test point that's not going to be a point on this line. It has to be either on the left side of this line or the right side of the line. And the test point that I'm going to select will be this point, the point 0, 0. Okay. My suggestion is always try to use 0, 0 wherever you can. Now, if 0, 0 is on the line, you'll have to select another test point that's not on the line. But since 0, 0 is a good test point, we'll use that. So here, x is 0 and y is 0. So that means I'm going to substitute the 0 in for x and for y in this equation, which is, of course, 4x minus 2y is greater than or equal to 8. So here, x is 0, so this will be 4 times 0 minus 2 times y, which is 0. That has to be greater than or equal to 8. Well, 4 times 0 is 0, minus 2 times 0, that's also 0. And if I do 0 minus 0, that's 0. is 0 greater than or equal to 8? And the answer will have to be false. Okay, so here we came up with a false statement. Okay, so that means we have to shade the half plane that does not contain this test point here. So we're not going to be able to shade this part. We have to shade this part right here. I'm going to use this right here to shade this part right here, because that's the part that does not include the test point. Because when I use that test point of 0, 0, I ended up getting a false statement. Okay, so all of that represents the graph of that inequality 4x minus 2y is greater than or equal to 8. Okay. All right, let's take a look at another example like this one. Let's say I want to graph y is equal to y is greater than negative 3/4 x. Okay. Now I'm going to graph this as if I was graphing the equation y is equal to negative 3/4 x. Let's see what that looks like. Well, notice since y is by itself and is equal to something, what I would do is use an XY table and just pick some values of x that I can easily find out what y is. Like for x is equal to 0. If I do negative 3/4 times 0, that's 0. Now I'm using 4 because notice my denominator is 4. Since x, and if I let x equals 4, this is what y would be equal to. Negative 3/4 times 4, and that 4 will be 4 over 1. Notice that these 4's divide out. You'll be left with negative 3. So for x equal 4, y is equal to negative 3. And let's go ahead and use negative 4, by the way. So that means y is equal to negative 3/4 times negative 4 over 1. Here the 4's again divide out, and also negative times negative will be a positive, so it'll be positive 3. So here's some points that we can use here. 0, 0, 4, negative 3, and negative 4, 3. So I'll plot those on the coordinate plane. Here's 0, 0. 4, negative 3 will be to the right 4 and down 3. Negative 4, 3 will be to the left 4 and up 3. Now my original inequality is strictly greater than. That will mean that the line that I will be drawing will not be included. So I'm going to connect those points and draw a dotted line or dashed line like this. So that would be the dashed line here. And then next, I'm going to select a test point. Now I can't use 0, 0 because that point is on this dashed line. So I'm going to have to use another test point, either here or here. And I'm going to use this test point right here, 0, 3. I'm just using that as a test point. And then I'm going to substitute the x with 0 and the y with 3 in that inequality. So let me rewrite the inequality. Y is greater than negative 3/4 x. And just substitute the x with 0 and the y with 3. So this will be 3 is greater than negative 3/4 times x, which is 0. Negative 3/4 times 0, of course, is 0. And is 3 greater than 0? It is. So this is a true statement. And since I came up with a true statement, I can shade the region or the half plane that contains the test point. So it's going to be this region right here that I will shade that contains that test point. Now, if it was a false statement, then I would shade the other region, the region below, or the one that doesn't contain the test point. All right, so that is the graph of that inequality, y is greater than negative 3/4 x. Okay. Now, the example 2 that I just did, where you have y is greater than negative 3/4 x, this also is helpful for graphing without using the test points here. Okay, because I could have graphed this without getting a test point of 0, 3. So on the next page, you'll see how we can graph a linear inequality without using test points. Okay, and this only applies if the inequality is of the form y is greater than mx plus b or y is less than mx plus b. Has to be one of those two forms in order for you to use to do the graph without using the test points. Okay. The inequality symbol indicates a half plane to shade. So if y is greater than mx plus b, you're going to shade the half plane above the line y equal mx plus b. Or if y is less than mx plus b, then you're going to shade the half plane below the line y is equal to mx plus b. So going back to that example 2 that I just did, as you can see here, for the y is greater than negative 3/4 x, y is already by itself, but here it says greater than. So that means I can shade the region above that line, which is what I did here. Okay, so now, next thing I need to talk about is this. It is also not necessary to use test points when graphing inequalities involving half planes on one side of a vertical or horizontal line. Okay, so here's some tips right here that is provided in this handout. If you have a vertical line, x is equal to a, and a is going to be some constant. So x equal to some constant means this. If x is greater than a, you're going to shade the half plane to the right of x is equal to a. Or if x is less than a, you're going to shade the half plane to the left of x is equal to a. And then for the horizontal line, y equal b, where b is some constant, so y equal to some constant b is this. If y is greater than b, you're going to shade the half plane above y equal b. Or if y is less than b, you're going to shade the half plane below the y equal b. Okay. Now let's look at a couple of examples of this. In this example 3, parts A and B, we're going to graph each inequality in a rectangular coordinate system. Like in part A, we got y is greater than 1. Y is greater than 1. Okay, so here we're going to graph this as if we were graphing y is equal to 1. And keep in mind, y equal to a constant means that your graph will be a horizontal line. And notice the inequality symbol, it says greater than. That means your line that you're going to draw will not be included. So, and it's a horizontal line because it's y is equal to something. But since it's greater than, we're going to do a dashed line. So here I'm doing a dashed line or a dotted line or dotted horizontal line going through the y-axis at 1. And since it says greater than, that means we're going to shade everything above the y-axis. I mean, above that dotted line. Okay. So this is how we shade everything above the dotted line to indicate that y is greater than 1. Okay. So that's the shaded region above y is equal to 1. And this is the graph of y is greater than 1. You have a dashed line going through the y-axis at 1. Everything above it is shaded. Part B, x is less than or equal to -2. Okay. Now we can graph this as if we were graphing x is equal to 2. And x equal to a constant means that we have a vertical line. X equal to a constant means we have a vertical line. So at -2, by the way, that should be -2. Okay. It says less than or equal to, so that means that the line will be included. So it's going to be a solid line, a solid vertical line going straight up and down, crossing the x-axis at -2. And it says less than, and that's included. The less than is included. So that means we shade everything to the left of this line. So you shade everything to the left. So we're going to shade this plane that's to the left of x is equal to 2. Okay. So that's what the graph of x is less than or equal to -2 looks like. Okay. All right, next we'll look at graphing a system of linear inequalities. Graphing a system of linear inequalities here. All right, the solution set of a system of linear inequalities in two variables is a set of all ordered pairs that satisfy each inequality in the system. Thus, to graph the system of inequalities in two variables, begin by graphing each individual inequality in the same rectangular coordinate system. And then you're going to find a region, if there is one, that is common to every graph in the system. This region of the intersection gives the picture of the system solution set. Okay, so you're going to graph each inequality in the same coordinate plane and then find that intersection. Okay, so like in example 4, here we're going to graph the solution set of x minus 3y is less than 6 and 2x plus 3y is greater than or equal to -6. All right, so let's start with that first inequality. X minus 3y is less than 6. X minus 3y is less than 6. All right, so I'm going to treat this as x minus 3y equal to 6 and graph this on the coordinate plane. Okay, since the x and the y are on one side and the numerical term is on the other side, let's use x and y intercepts. So again, to find the x-intercept, you have to let x equal 0. And so, take that back, let y equal 0 and solve the x. Let y equal 0 and solve the x. Okay, so bring down the x minus 3 times, I'm substituting 0 in for y. That'd be equal to 6. Well, 3 times 0 is 0. You'll be left with just x. And that's x is equal to 6. So my x-intercept is the ordered pair 6, 0. And then for the y-intercept, here we're going to let x equal 0 and solve for y in this equation. So here x is equal to 0. This will be 0 minus 3y is equal to 6. Substituting x with 0. 0 minus 3y is negative 3y. That's equal to 6. And if I divide both sides by negative 3, I'll get y is equal to negative 2. So 0, negative 2, I have to get the negative. 0, negative 2 is my y-intercept. And now I'm going to plot those intercepts on the coordinate plane. So 6, 0 would be to the right, 6 to the right, and on the x-axis. 0, negative 2, we stay at 0, but go down 2. Now, the original inequality says less than. That would mean that this line would be a dashed line or a broken line or a dotted line. So I'm going to draw a dotted line. Like this. And of course, I do need a test point. And in this case, my test point, since 0, 0 is not on that line, I'll use that as a real good test point. And then substitute the x and the y in that equation up here, that x minus 3y is less than 6. X is 0, minus 3 times y, which is 0, less than 6. Let's see, bring down the 0. Minus 3 times 0 is 0. Well, 0 minus 0 is 0. And is 0 less than 6? It is. So this is true. So that means if I was just graphing this, I would have to shade everything that contains this test point, which is 0, 0. So I'll be shading this part right here. Okay, so I'm just drawing this in. And now for the other equation, 2x plus 3y is greater than or equal to negative 6. I'm going to do this on the right side. 2x plus 3y greater than or equal to negative 6. I'm going to graph this as if I was graphing 2x plus 3y equal to negative 6. And then graph this, just do this just like I did x minus 3y is less than 6. Find the intercepts, both the x and the y-intercept. So for the x-intercept, we let y equal 0 and solve the x. We let y equal 0 and solve the x. So in this case here, bring down the 2x plus, substitute the 0 in for y, so the 2x plus 3 times 0, that's going to be equal to negative 6. And what will happen here is that 3 times 0 will be 0. So I'll be left with 2x equal negative 6. Then divide both sides by 2. You'll get x is equal to negative 3. So my x-intercept will be negative 3, 0. And then for the y-intercept, Here I let x equal 0 and solve for y. So in this case here in that equation, 2 times, I'm substituting the x with 0 plus 3y, and that's equal to -6. Well, 2 times 0 would give me 0, but so I'll be left with 3y equal -6. Divide both sides by 3, you get y is equal to -2. So my y-intercept is the ordered pair 0, -2. Okay. Now I'm going to do this in a different color. I'm going to plot a line in a different color, like this here. For -3, 0 will be to the left 3 on the x-axis. 0, -2, we stay at 0 but go down 2. That's going to be this point right here. And the original inequality, if you look at it, was greater than or equal to. That is going to be a solid line this time. So I'm going to draw a solid line. That's going to be a solid line. Okay. All right, now I need a test point. Well, guess what? I can also use 0, 0 as a test point since 0, 0 is not on that line. And then just substitute into that second inequality. And I'll write that as 2x plus 3y greater than or equal to -6. Substitute 0 in for x and 0 in for y. 2 times 0 is 0. 3 times 0 is 0. 0 plus 0 is 0. And is 0 greater than or equal to -6? That's also true. Okay. So now, normally I would shade the region that has the test point 0, 0. That's going to be this region above that red line. Now, if you take a look at this graph here, I need to find the region where these red lines and the black lines intersect. If you look at it, it's this region right here, where I have both the black and the red lines intersecting. That is going to be the region that will satisfy this inequality. Okay. So here, this is what I will shade. This is the region that I'm going to shade right here. That's the region I shade, where the black lines and the red lines cross in this case. So that region represents the graph of the system x minus 3y is less than 6 and 2x plus 3y is greater than or equal to -6. Okay. And again, do feel free to pause the video if you need to try to catch up with some of the things I'm teaching in this video or explaining in this video. Okay, here's another example. Let's say I want to graph the solution set of the system y is greater than or equal to x squared minus 4 and x plus y is less than or equal to 2. Okay. So now let's look at y is greater than or equal to x squared minus 4. And I'm going to graph this as if I was graphing the equation y is equal to x squared minus 4. And since I got x squared in it, I do have a quadratic equation. So another graph of this would be in the shape of what we call a parabola. And basically what I can do here is just create an XY table and just pick some values of x, like for x is 0, this will be 0 squared, that's 0, minus 4, which will be negative 4. For x is equal to 1. 1 squared will be 1. 1 minus 4 will be negative 3. For 2, 2 squared, or 2 times 2, will be 4, minus 4, which is 0. Now I'll pick some negative numbers like negative 1 and negative 2. Negative 1, u squared is like negative 1 times negative 1, which is 1. 1 minus 4 is negative 3. And then 2 squared, negative 2 squared, or negative 2 times negative 2 will be 4. 4 minus 4 is 0. So these are some ordered pairs that I can use here. Okay, so 0, negative 4 will stay at 0, but go down 4. Negative 1, 1 negative 3 will be to the right 1 and down 3. 2, 0 will be to the right 2 and on the x-axis. And negative 1, negative 3 to the left 1 and down 3. Negative 2, 0 to the left 2 and on the x-axis. All right, let me pick some more points like 3, negative 3. If x is 3, 3 squared, or 3 times 3 is 9. 9 minus 4 will be 5. And for negative 3, that'll be negative 3 squared, or 9 minus 4, which will be 5 as well. So 3 and up 5, and also negative 3 up 5. So this will be a better graph of what that parabola will look like. Okay. Now notice something here in this equation. Y is greater than or equal to. If you recall, back to our notes here, if you have something like this, y is greater than whatever, you shade the half plane above that line. In this case, it's a parabola, so we have y is greater than or equal to something. That means we can shade above this parabola. Okay. Now, of course, you can do a test point if you wanted to. But okay, we'll go and do a test point anyway to convince you that you're going to have to shade above. Your test point will be 0, 0. So here, using this equation, y squared is y is greater than x squared minus 4. Substitute 0 in for y, so the 0 is greater than or equal to x is 0, that's squared, minus 4. 0 squared is 0, minus 4 will be negative 4. And 0 is greater than negative 4, so that's true. So we're going to shade this area that contains that test point, which is the origin, 0, 0. So this, no, not ready for that yet. So it's this part that we're going to shade. Okay. Now, for the other point, line, x plus y is less than or equal to 2. Okay. I'm going to graph the line x plus y is equal to 2 using intercepts, since the x and the y are on the left side. So for the x-intercept, you have to let y equal 0 and solve for x. So this will be x plus y is going to be 0 is equal to 2. Well, x plus 0 is x, so x is equal to 2. So 2, 0 will be your x-intercept. And then for the y-intercept, here you let x equal 0 and solve for y. So your x is going to be 0 plus y is equal to 2. 0 plus y would just be y, so y is equal to 2. So the ordered pair 0, 2 will be your y-intercept. Okay. I'll plot those. 2, 0 will be right here to the right turn on the x-axis. 0, 2 will stay at 0 but go up 2. That would be this point right here. Less than or equal to means that this line will be included. So I will be drawing a solid line. Okay. Now I need a test point to see which side I need to shade. I can also use 0, 0 since the line doesn't cross the origin, 0, 0. Using this inequality, x is 0, y is 0. That has to be less than or equal to 2. 0 plus 0 is 0, and 0 is less than 2. So that's true. So I'm going to be shading the bottom part that contains that test point that I used. Now, I need to shade the region that has the intersection of the red and the black. And that's going to be this part right here, as you can see. So it's going to be this region right down here that satisfies that system of inequalities. Okay. So this shaded region right here represents the graph of the inequality y is greater than or equal to x squared minus 4, and x plus y is less than or equal to 2. Okay. As you can see, I'm trying to fit all of this on one screen. Okay. So if you need to, you can try to pause the video and try to get all this down. All right, now I got one more example. Let's say we have 3 different equations here. And I want to graph the solution set of this system. X plus y is less than 2. And negative 2 is less than or equal to x and less than 1. And y is greater than negative 3. Now the first inequality we might need to do a little work on this one, because here we got x plus y is less than 2. X plus y is less than 2. So we want to graph this as if it was x plus y is equal to 2. Now we can use x and y intercepts to graph this. So again, to find the x-intercept, I'm just abbreviating, we let y equal 0 and solve for x. So in this equation here, I'm going to bring down the x plus y will be replaced with 0, and that's equal to 2. X plus 0 is just x, so x is equal to 2. So the ordered pair for that x-intercept would be 2, 0. And then for the y-intercept, again, I'm abbreviating here, we let x equal 0 and solve for y. So here x is 0, so this will be 0 plus 2, 0 plus y. And since I'm letting x equal 0, that's the equation. So it'll be 0 plus y is equal to 2. Well, 0 plus y will be y, so y is equal to 2. So the order pair 0, 2 is your y-intercept. Okay, I'll plot those on the coordinate plane. 2, 0 will be on the x-axis. 0, 2 will be on the y-axis. Notice the inequality says strictly less than. So the line will not be included. So I'm going to draw a dashed line here. Okay. Because that means that line will not be included. And now I need a test point to find out which region I need to shade. A good test point would be the ordered pair 0, 0. Okay, and using that x plus y is less than 2, x is 0 and y is 0. And that's going to be less than 2. 0 plus 0 is 0, which is less than 2. And that's true. So I know I'm going to be shading the region below. And it contains the test point. Okay. So that's for the first inequality. Now for the second inequality, if you look at this one, -2 is less than or equal to x and less than 1. Well, this means that x is greater than or equal to -2 and x is less than 1. That's what this means. Now I'll write this out for you. X is greater than or equal to -2 and x is less than 1. Those are going to be two vertical dotted lines. Okay. Now, just two vertical lines. One will be dotted, the other one will be solid. Like for x is greater than or equal to -2, that would be a shaded line. And let me do this in red. No, let me do this in green. Sorry. Just trying to pick my colors. So at -2 is going to be a vertical solid line. Solid. Because of the equal to sign underneath it. But for x is less than 1, it's going to be a dashed line or a vertical dotted line at x is equal to 1. Like this. Now, to indicate that x is in between -2 and 1, we're going to shade in between those two boundaries. We're just going to shade in between those two vertical lines, as you can see. And then the third one is y is greater than -3. So I'm going to graph that as if I was graphing y is equal to -3. Well, for y equals to -3, that would be a horizontal line going this way at -3. But it just says strictly greater than, so I have to draw a broken line or a dotted line through the y-axis at -3. And since it says greater than, we shade above. Here I'm shading above y=3. Okay, now here comes the hard part, or the fun part. I need to find out the area, or shade the region, where the black line, the red line, and the green line intersect. All right, now you can look very carefully. That region is going to be this part right here that I'm outlining. Here, all the way to here, and on the right side. And I will shade that region. So that would be that region that satisfies all 3 inequalities. Okay. So that's the graph of this system of inequalities here. X plus y is less than 2, -2 is less than or equal to x, and less than 1, and y is greater than -3. Okay. Okay, so that will complete this video on section 5.5, dealing with systems of inequalities. All right, so attempt the homework. Feel free to email me or ask questions if you have any problems or you need to have some clarification on what's in this video and in the homework. Okay, take care.